Welcome to IT.Solution, your total network, system, firewall, and security partner.
Welcome to The Explainer. Today, we are diving into the high-stakes, largely invisible battle that's probably happening right now on your network. We're talking about the clash between relentless threat actors and the network defenders standing in their way. Look, whether you're managing a small home office or a sprawling enterprise network, these fundamentals are the absolute bedrock of keeping your data safe. Here is our roadmap for today. We'll start with the landscape of risk, move right into the anatomy of network attacks, explore the defense-in-depth strategy, break down AAA, firewalls, and IPS, and finally finish up with hardening network devices. Let's get right to it. Before we start building up our digital castle walls, we really need to ask ourselves a pretty fundamental question. What are the true stakes here? When a network is under attack, what are we actually protecting? Well, in the networking world, a breach can mean devastating information theft, massive data loss, or even a total disruption of service that just brings a business to a grinding halt. Understanding exactly what you have to lose is always step one in deciding how to protect it. Okay, Section 1, the landscape of risk. Let's lay down some essential terminology. Think like an attacker for a second. They aren't magic, right? They're really just looking for a vulnerability. And a vulnerability is simply a weakness in your system, your software, or your overall network design. Think of it like an unlocked window on the ground floor of a building, or maybe a technological flaw and a piece of code that just hasn't been patched yet. It isn't the attack itself, it's the opportunity for an attack. Now, if the vulnerability is that unlocked window, the threat is the potential danger. It's the malicious actor actively peering through the glass, or a piece of automated malware roaming the internet looking for an entry point. Basically, it's anything that represents a real danger to your company's assets, data, or network functionality. Next up, we have the exploit. The exploit is the precise mechanism that the attacker uses to pry that unlocked window all the way open and get inside. It's the tool that bridges the gap between the threat and the vulnerability. When a threat actor successfully runs an exploit against a vulnerability, well, your network is officially compromised. In wrapping up these core concepts, we have to look at risk. Risk is the overarching calculation of the big picture. It's the actual likelihood that a specific threat is going to exploit a specific vulnerability to negatively affect your organization. Managing risk really just means figuring out which unlocked windows matter the absolute most and prioritizing fixing those first. You know, when we talk about this stuff, it's super easy to picture a hacker in a hoodie typing furiously away in a dark room. But not all vulnerabilities are digital. Physical threats are honestly just as dangerous. We're talking hardware damage, extreme temperatures messing with server rooms, electrical spikes, or even just poor maintenance like static discharge or bad cabling. An attacker, or honestly just really bad luck, can completely take down a network simply by altering the physical environment. Securing that physical space is just as vital as securing the digital one. Moving on to Section 2, the anatomy of network attacks. Let's look at the weapons and methods they use. It is absolutely crucial to understand the difference between where these attacks originate. External threats are the ones we constantly hear about on the news, right? Viruses, zero-day exploits, or massive denial-of-service attacks just hammering your network from the outside internet. But internal threats are equally, if not more, dangerous. Yes, this could be a malicious employee, but way more often, it's just an honest mistake. It's someone losing a company laptop in an airport, or an employee accidentally misusing their access privileges. Once a threat actor decides they are targeting your network, they often rely on access attacks to get their foot in the door. Let's look at 4 common methods. Password attacks try to brute force or sniff out login credentials. Trust exploitation leverages compromised privileges to dig even deeper into the system. Port redirection uses a machine they've already compromised inside the network as a jumping-off point to attack other trusted servers. And then you have the man-in-the-middle attack, where they secretly intercept and maybe even alter data flowing between 2 legitimate users. Their ultimate goal with all of these? Retrieve sensitive data or escalate their privileges to full administrator status. So seeing just how many ways an attacker can strike us, physically, externally with malware, internally via human error, and through these complex access attacks, how do we possibly defend our digital castles? Like, is it even possible at this point? That brings us to Section 3, the defense-in-depth strategy. It is all about taking a layered approach. To build a true, robust perimeter, network administrators have to combine software, hardware security, and physical access prevention to block intruders at literally every possible gate. Think about your house. You don't just put a lock on the front door, you lock the interior doors, maybe you add some security cameras, and, if you're really serious, you hire a guard. In networking, we do the exact same thing. Defense in depth literally means deploying multiple specialized security devices in tandem. You might use a VPN to encrypt your data traveling across the internet, an ASA firewall to heavily guard the perimeter, an IPS to actively hunt for malicious traffic, dedicated email and web security appliances to filter out phishing and malware, and an AAA server to manage exactly who is even allowed to log in. By stacking these layers, you ensure that if an attacker somehow manages to breach one, another completely different roadblock is waiting right there for them. Section 4. Let's get into the specifics of AAA, firewalls, and IPS. Let's kick this off with AAA. Honestly, the easiest way to think about this framework is like a credit card. First, authentication. It verifies your identity. Are you actually who you say you are? Second, authorization. This sets your spending limit. Just because you're allowed inside the building doesn't mean you get the keys to the server room. What specific actions are you permitted to take? Finally, accounting. This tracks your purchases. It keeps a meticulous, running log of everything you did while you were connected, which is absolutely vital for auditing if something goes wrong later. Right behind those AAA checkpoints, your firewalls are standing by as the steadfast guards enforcing your access control policies. And they do this using some very distinct filtering methods. They can look at the label on the box using packet filtering to block bad IP or MAC addresses. They can look inside the box using application filtering to stop specific programs based on ports. They use URL filtering to block known malicious websites. And incredibly, with stateful packet inspection, they actually remember the context of a conversation. They ensure that any incoming data was actually requested by someone inside your network, and they immediately drop anything unsolicited. But here's the thing. Firewalls can't catch everything. To defend against those really fast-moving, complex attacks that might slip past a standard firewall, you deploy an IPS. An intrusion prevention system actively scans the traffic flowing through it for known malicious signatures. It can spot an attack hidden inside a single packet, which we call an atomic signature, or it can recognize a composite attack that's spread across multiple packets. Once it spots them, it drops that dangerous traffic immediately before it ever reaches your endpoints. Which leads us perfectly into Section 5, Hardening Network Devices. It's time to lock things down internally. If a threat actor somehow sneaks past the firewall, their very next target is going to be your internal routers and switches. So, to harden these devices, network admins use specific configuration commands. You've got to enforce minimum password lengths, usually at least 10 characters. You use commands like service password encryption to encrypt all those passwords so they aren't just sitting there in plain text. You absolutely need to set the system to deter brute force guessing, usually by blocking logins after too many failed attempts, and make sure any inactive administrative sessions time out automatically. And finally, never, ever use unencrypted protocols like Telnet. Mandate secure access like SSH. But the ultimate challenge in our industry isn't entirely digital. You can layer up the best firewalls, deploy top-tier IPS, and implement flawless device hardening. But at the end of the day, securing endpoint devices involves human nature. You still have to train your employees not to click on that free vacation phishing link, or write their highly secure 10-character encrypted password on a bright yellow sticky note attached right to their monitor. So I want to leave you with a final thought to ponder about your own environment. Considering all the advanced firewalls and device hardening techniques we just talked about, is the human element actually the weakest link in your network? Understanding how to deploy and secure the technology is incredibly powerful, but it really is only half the battle. If your users aren't an active part of your defense-in-depth strategy, well, your walls might not be nearly as high as you think. Thanks so much for joining me for this explainer, and I'll see you in the next one.
Thank you for watching. See you in the next episode.